Hello friends, welcome to the Laptex. I am again with the same case study which I asked the question to you. So let's start it from the place where we have left in last video. We are not getting PAC in on across the register. This was the scenario we have left. Now you can see that the status here. So now you can see that this is the board and the place where we have shown you. Let me zoom it. So this is the place on this area. Let me show you once again. On this area we have voltage available. Let me inject the DC jack into the board. We will try to cover this case study in short time because we have to go to home now. Here we are getting 3 volt, but across the register we are not getting voltage. Even if with the help of tweezer we try to pass on, but still you can check on the tweezer. This is 0.46 volt. In that case, what else is remaining? This is what we have asked, and you have tried to give a lots of good answers. So we are getting encouraged by your comments. So thank you for that. Now, the area which you have to see here is AC on, because AC off also we have removed, but no help, nothing improvement we have got. So now paste it and let's find AC on, and here it is on the same op amp, but with a different terminal. On the different terminal it is going. So here we have seen that PAC in how this is generated. This is the part 1 A1 PU101A, and this is the B. Okay, PU101B. Now in this terminal it is coming. This is a kind of switch. Okay, so and whether it will be off or on, P charge. So now let's start this point from the beginning. So where it is going to begin. So this VS 20 volt will pass across this parallel resistor, and you know the concept of the parallel resistor, and then across this diode it will enter here, and through the AC off signal this will switch on and this voltage will become B plus. Now B plus will be divided into the voltage divider, and here whatever the amount of voltage we will get on this area. Now the same concept, because it is the positive feedback. Okay, it is the non-inverting terminal feedback, so it is a relaxation circuit or oscillator you can call it. Now here this is the 3 volt or 3.3 volt. You have to see which one is greater. According to that you have to see that the VL voltage will be determined here in between. If this is the greater to this voltage, then this diode will be off, and if this voltage is low, then this AC on or main on signal will switch on, or this will switch on this PD. Now it will become the P charge. This is the calculation of this. Now we have to check PD 102. Now let's come and search PD 102. It is really terrible that this particular board has no board view. So here is the PD 102. Now let's check on this point. It is powered on, and we have to check voltage. These are the resistor which we have seen. It was 1 kilo ohm resistor. All are the 1 kilo ohm resistor, as the marking is 102. So 2 is 20. So it becomes the 1000 ohm. It is called 1 kilo ohm. Now on this resistor we have 18 volt. That's all right. On this side we have 4 volt. Also on the diode we have 4 volt. On this side, Zener value after Zener value, since it is on the series. So now you can check here 4.2 volt. First of all you have to confirm that what is the Zener value. Now one thing is that since it is on the parallel, the resistor is on the parallel, so you know very well that it will reduce the current, not the voltage. So now we need to get voltage on this area also, the 20 volt. or the 18V if we are getting here, so 18 volt we will get on this point. So the voltage is stopped, maybe because of the resistor value is increased, or maybe the PD is open, and maybe something happened or short. So let's do one thing. Let's remove the DC jack and check the resistor value. So what amount of resistor value? 1/3 we will get. 1/3, around 300 ohm we will get if we check any of the resistor on the parallel value. Okay. So now let's come and check the resistor. So let's see the value here. So 3 resistor on the parallel, 330 ohm, only 330 ohm, as I told you, 1/3 we will get here. So this is what we are getting. So the value is absolutely okay. One single resistor value is 1 kilo ohm, but since it is on the parallel, so that is why if you calculate it, the resistor value you will get, individual value you will get around 330 ohm. So resistor value is absolutely fine. Now diode could be faulty, or wherever it is going could be faulty. So let's begin it to remove PQ102. If there is any problem, like even problem is on this side, like here there is a shorting or something not okay, it will go reverse, and this diode is on the switching through this area, and it could stop this voltage to go ahead. So now remove this PQ102 first. So it is let me zoom it, PQ102. So here I would like to mention one thing. The diode you are able to see on the board, this diode I have removed, PD103, this diode. When I remove this PD103, this diode, so my second MOSFET got shorted. This one. Now you can see here, this MOSFET got shorted. I have replaced it with new one. So PQ 304 got shorted when I removed and powered this one. Now you can see PD103, when I removed and I injected the DC jack into the board, it got massive shorting, and this is the MOSFET. Now you can see here, this is the MOSFET which is shorted from the drain to source. Now let me show you. So this is the MOSFET which has shorted. Now how it is shorted, let me show you. So it is on the beep. Now you will see, now 0, it became 0. So now I will not make such a mistake. Now this time what I am going to do here, that I am going to remove this PQ102, and now I will inject the DC jack. So now you also enjoy. If anything goes wrong, you will see. Now ampere is not going up, as it was 0.068 milliampere. Now it is stopped at the right point, 0.19. Now that voltage which was missing on the across the resistor of parallel resistor, inside 20 volt, outside also 20 volt, on the diode, now you also see. So inside the parallel resistor 20 volt, outside the parallel resistor 20 volt, on the Xeno diode PD102 20 volt, and 19.6 volt, that is the drop of voltage. PD on the PD102 we are getting 19.6 volt. Now this voltage is reaching on this point which we have removed, that is the PQ102. Okay. So here 9 volt, that is the voltage divider. AC off is coming, and through the AC off there is the 100k, it is going ground here. Now I think this one, yes, ground has gone here. Now on we are getting 9 volt on the gate. How we are getting here? AC off, we are getting ground, because on the adapter mod the ground will come here, so it will not switch on. So the 20 volt is coming across this register and going on the gate of this NPN. Okay, so NPN, here it will switch on and it become ground here. Across this register it become the voltage divider. So 20 volt, around 10 volt you will get on the gate of this. So this is what we are getting here. Now let me check it once again. You will see around 9.7 volt you are getting on the gate. Okay, and one side there must be 20 volt. Yes, on the other side maybe something is problem, because when this is connected all the voltage is reduced. So this area has any problem and I don't know what is the problem. Let's check the cold. On cold, what is the value? It is 1.9. Maybe it will rise because right now I have removed the power. So now it is 1.9 ohm. So this is quite definite that if this side is short, this shorting is sinking entire current along with the voltage. So this is the problem. So we need to confirm that what is short on this point. Okay, what is short on this point? So make it confirm once again. 1.8. So now let's see how we will try to remove shorting from the motherboard. So now let me show you once again. You will check. Now you will check. I will try to zoom it. It is not good zoom through the mobile. So here 1.8 volt we are getting on the same point. What we will do, here is my 10 amp power supply. We will inject some voltage in order to find out that what area has problem. Now this is the very common fault in the Lenovo models, where the 51 on logic you will get. Here what you have to do, the area, the same area where you are getting the 1.8 volt, where the B plus voltage is need to be generated, this area we are going to inject 1.5. Okay, since it is the 2-digit, my 10 ampere power supply has 2-digit. You can see here like 300 milliamp, you can call it, not 32. So now we are going to increase the voltage. Okay, now you can see the 0.44, it is going to be 1 amp. Now it is half amp. Okay, 2 volt I have injected. Now you can see 3 volt, it has reached 700, 900. Now 1 amp. Now you can see as I have increased the 3 volt, at the very area we are expecting 19 volt. Merely we have injected 3 volt and ampere is going up and up, more than 1 amp. Now what we will do, I will take help of Dildar sir. Dildar sir, you come here and you keep on searching where is the fever. So now op amp, we are expecting op amp that might be faulty, other area, and the best sensor as we have our hand. So I need to remove my gloves. In this area nothing is hitting up. PCH is hitting up too much. Okay, PCH is hitting up too much. Why is that hitting up? So PCH is hitting up too much on this area. If I tell Dildar sir to show on this area on the PCH, you will be able to see 37 degrees Celsius, it's going up. Let me check once charging IC. So this area has some problem. Maybe I have to check more points like what is the value of PCH. Also I need to confirm. So guys, now this time I am going to jumper this point and I will touch by hand in order to confirm exact location, exact point that which is causing to stop this voltage. Now the same area I will jumper. Now you also enjoy. On this area we are going to jumper because this is the point where the shorting is. coming. Now jumper this area. Okay. So now what we will do now, we are going to connect the positive terminal. This is the positive terminal. We are going to connect on this same point and negative to the ground. Now we will increase the voltage and we will check one by one that which one is getting heat up. If anything is suspected, I will remove. So here, no, nothing is heating up on this area. Let's move this side. Processor, we need to remove the processor. Let's turn off. Now I will turn it on and now you will see PCH is heating up badly. Rest 3.3 and 5 volt area is heating up. Now I will tell to Didar sir to show. This is the area, I think. This is the temperature, environment temperature. Now you will see on this point. Yes, 36 on that, 38, 39. Okay, so high drive must be having problem. The 3.3 and 5 volt area, this is the 3.3 and 5 volt area. Okay, so this is hitting up and now you can also check on this area. Here is the point, you can check 41 degree it is going. So we cannot judge quickly that the PCH is bad. Some of the time this could also cause. Now we will check manually that with the multimeter that what is the value. Now you can check 19 volt high drive MOSFET is short. So in this way we can say that the high drive of 3 volt, that is the 19 volt, which is short. So this capacitor is causing to stop entire motherboard voltage, even PACIN. Okay, so let's remove the MOSFET. This is the MOSFET which is too much heating up. We are going to remove this. So here is the point I have shown you. Here is the point I have shown you. Now you can check also. This is short. So what we have learned today, that we must ensure those points which we have told you in our class, that how you have to check in cold. If you do not check cold, because there are the various parts of voltage like VAS voltage and then become the B plus voltage, then BAT voltage, then it became VVP. I will show you that how many terminology for 19 volt are used in this type of architecture of motherboard. So in this way you might get confused that how many area I need to check. So but better to check at least high drive side of any regulator, so that you can confirm that 19 volt is okay or not. But the purpose of making this case study to enhance your knowledge, like we have described you here that how op-amp work, only greater voltage you have to check. So you have liked this video before video also, and I am expecting that you will like this video also. Now let me check. So now the shorting gone. Okay, shorting gone. And now let me check the MOSFET. So N channel MOSFET is short in this board. Now I need to replace with some scrap motherboard. So let me remove one. So I have 4800, that is the N channel MOSFET, and I will remove it and I will replace it. So in fact it's not a great deal to remove shorting from the board, while some component are shown or the blast marking is there. The purpose of understanding this case study, that how you will have to follow the schematic, because in practical the 51 on logic and AC concept, AC PAC in concept, however these are depend on the architecture. Different type of architecture use the different type of terminology. So Dildar sir has described in the switching. So if you are also interested in our video classes, then you can also contact on the given number. It is fixed now. Let me little bit, we are going to fix the pin There should not be any mistake. Like sometime if gate voltage is not properly connected, then that could cause 3.3 volt shorting. Now let's make it clean like this. That's all right. So now you see what type of MOSFET was used earlier. All type of MOSFET are different. So it's all right. You need to understand only that which one will be compatible. What I will do now, here is my blank space. I need to remove this point. First of all, things need to be confirmed that this area shorting is gone or not. Then I will use the transistor which I have removed from the board. Now you see earlier it was having beep with 2 ohm at 3 ohm. Now the value in the kilo ohm will go around 80 kilo ohm. Now we are going to fix back the transistor PQ 102. And believe me, I was expecting that my LM309 is having problem. However, from the beginning, I did not check shorting in the board. Maybe that through shorting you could find out that that particular area is not functioning, but this is a common fault. Yes, sometimes you do not get 19 volt on the motherboard without shorting. That is why this case study is essential for you. Okay, because many time I have made a case study of this. This that is the paid case study. This is also a kind of paid case study I am giving you free of cost. So I am just seeking for your comment and like. Now let me inject the power. You also see. So we are going to inject power. Now it is turned on, I think. Let me check the value because processor is not in the board. That is why we need to confirm that 3.3 and 5 volt available or not. 3 volt, this is the 5 volt. Okay, now 19 volt was missing on the diode. We are getting voltages. Okay, everything is working fine. Now let me use the processor, and also a RAM is required. This is my RAM. I got without RAM, and I don't have anything to check except this keyboard. The good thing about this board, that this board is very fresh. I have received without working. Now let me inject. It is turned on, but still I hope that the PCH is not safe, as it was getting hot too much. Voltages are okay. Display has not come. Once I will change processor and check the voltage, remaining thing you know better that it was getting heat up too much, and that might be faulty. I will give estimate to my customer that I need to replace the PCH, and PCH number is SLJ8C, that is the HM76. Once I will check with my processor, still the same value. So I will diagnose it, and if the this case that case study worth recording for you, I will surely record that what signal is missing in the board and why I have to change it. So hopefully guys, you have enjoyed and you have learned a lot. If you are required high level of training and advanced training, then you must contact on the given number. So hope that you will comment and you will like this video. Thank you guys. Thank you for watching this video.